I think we can start. Fine. You have your coffee, food, everything. It's fine. Okay. Yeah. What should I say? In German, I would have said Nicolai, bekannt von Film und Fernsehen, so known from TV shows and YouTube and whatever. And yeah, he just recently mixed up the whole Java community again with switching to a new role. Okay, it's not so recently, but you know, I'm a little bit slow. No.
Which switch are you talking about? I'm curious myself now.
No, that you're talking about Java from Oracle and everything. It's not that recent, but yes. And he will present us how these features that we love in new versions are coming to our IDE. And yeah. I want to give you the floor now.
Sure. Thank you, Tobias. Welcome, everybody. So, surprise English talk, as we just found out. And usually, yes, I'm well known from television and YouTube, usually with a different haircut. I'm very sorry if you came here for that. It's like I didn't get around to get to the hairdresser, so have this. This is not a haircut. This is just a leftover from a haircut like 8 weeks ago. I'm sorry about that. Okay, let's talk about this. Let's talk about how features get from an idea into the IDE that you can use. Who has used this feature? Great, quite a few people. So this is text blocks. Text block is a multi-line string literal that avoids the need for most escape sequences, blah, 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 blah. Let's go over the details. It's not about that specifically. It's a language feature that was added in Java 15. And there are also some small changes in the related API. But what is a feature in Java really? Like, it's something you can use, but what sits on the other end of that? What does Java have to do to give you that feature? And a big part of that is the specification. You don't need to read this, just for demonstration purposes. This is part of the Java language specification, which specifies the entire Java language. And as you can see, it has quite a deep table of contents. This is 3.10.6 on text blocks, and explains the syntax and the semantics and all that good stuff. There's more to documentation than the JLS. This is if you go to the Java 21 documentation page. In the bottom right, you will see the specification block, which contains language and VM specification here, and then the API documentation, and there's more. So there's a bunch of documents that make up the Java documentation overall, or the Java specification overall. But surely the Java language specification itself, the JLS, is the biggest and most important part there. Followed by the Java virtual machine specification, which is also very important because it specifies how the VM has to behave. Now, if you're an architect in your team, you think you're done the specification, that's all. If you also write code, you know you actually do need code that implements the feature that somebody else promised. And that's the second part. That's the second artifact that make up a Java language feature. One is the specification, the other one is the implementation. That lives in OpenJDK, and if you go to github.com/openjdk/jdk, you will find the code base that implements all this. OpenJDK is a community that develops this specific code base. It doesn't really ship binaries. When you ever hear somebody say, I use OpenJDK, then that's probably true, but they don't get it from OpenJDK. Somebody else builds OpenJDK. But it's a little bit of a sidetrack here. What I'm saying is, specification is one part, implementation is the other part. The hallmark of all Java features is that they come as syntax, VM, or API capabilities, or any combination thereof. As I said, they are specified, and they fulfill clearly defined requirements that have been researched before that. And ideally, they fit in seamlessly. And you just see that feature, and you're wondering, why did this take so long? Why did text blocks take so long? And the reason why I'm saying ideally you ask yourself that is because if the feature is complex and it looks complex, that means all the complexity has been exposed to you. Ideally, the complexity is hidden from you, or at least you don't have to attack it on the first day. So a feature is supposed to be simple to use, regardless of how complicated the implementation might be, right? So just because something is difficult on the VM level does not mean it should be difficult for us developers. But how do we get there? How do we get from idea to this point where something is so ready that it takes so long? That takes quite a while. Usually somebody does have an idea about something that should be improved, needs to be refined in an exploration to try to figure out whether this is an actual problem that needs solving and what the solution looks like or could look like. Prototypes and proposal come after that once a solution has been identified as promising. Usually we get to a preview feature then. That phase is somewhat new. In the end, we have the final feature, like text blocks. And what I want to do with you today is to go through this list from bottom to top. We just talked about finalized features and what that means, JLS and the implementation. And now let's go backwards in time and see the different steps that these features take to get there. So let's start with the preview phase. If you are using or have experimented with JDK 21, that has a bunch of preview features. That's more or less coincidental, like nobody planned that Java 21 is going to have all of these previews. It's just something that happened because all the projects working on them came ahead here in this version, and that's why they're all merged here. So something that you've seen earlier maybe was string templates and unnamed patterns and variables. Those are both preview features that you can already experiment with. There was also a talk on structured concurrency that is likewise a preview feature. Now what does it mean? I told you earlier, language features have specification and implementation. Let's talk about those parts. Let's talk about the specification first. The concept of preview features was introduced in JDK Enhancement Proposal 12. If you wonder about this low number and think it must hence be very, very old because the current JEP numbers are in the 400s, that's because the first 100 numbers are blocked for organizational JEPs. So this JEP 12 is not terribly new. It's a few years old, but it's not as old as you would guess just from the number. And it was refined by a recent JEP draft, which for, to me, unknown reason, very annoyingly, did not finalize, really. But it's also specified in the Java language specification. So the JLS specifies what a preview feature is and how it behaves. This is part of that definition. And laid out here is what conditions must a preview feature fulfill. So just because it's preview does not mean it's just random. It follows basically the same set of pretty strict rules. So the JLS lays out how a preview feature works and also lists all current preview features. And then there's basically a diff appended to that that says, okay, if this feature would become final, then the JLS would change as follows. We'll see that in a second. And it's also implemented already in OpenJDK, right? The preview feature is not just text in a spec or in a JEP or in a block or in a video. It actually works. If you go into the code base, you will see it there. And if you run somebody's build of OpenJDK, you will also have the preview feature in there. So this is what it looks like for text blocks. So in Java 14, when text blocks was still in preview, it mentioned at the top preview features, pattern matching, for instance, of records and text blocks. And if you click on text blocks, that's a link, you will see this thing, which, we don't need to go into details clearly, but you can see it's a diff. It has some red and some green blocks. And you can see this whole big new block. That was what I showed you earlier. Was that 3.10.6 or something? That's the big chunk where text blocks gets added and defined. And in some other places, it needs to be referenced. So that's where all the other stuff comes in. So preview feature is also specified. And I said it's also implemented, but you need to unlock it. We're going to talk in a second why that is the case. Let's talk about how at the moment. So when I have this example of a text block, that is what would work since Java 15. This just works. But let's say I was on Java 14, and I'll try to compile this with Java 14. I would say Java C text blocks, and I would get an error that says text blocks are a preview feature and are disabled by default. Use enable preview to enable text blocks. So the compiler recognizes the feature, but tells me you can't just do, no, that never happened. Sorry. You can't just use it as is, you have to enable preview features. And if you do that, you also have to specify the version, but let's ignore that. If I do Java C enable preview, then it works, and I get a compile warning that says, hey, you're using a preview language feature. Please be aware of that. Now I got it to compile. If I try to run, I get the same problem again. Java text blocks, so this is to run it, and I get unsupported class file version, blah, blah, blah. Preview features are not enabled. Try running with enable preview. So here we run into the first interesting thing. At runtime, the text blocks feature doesn't even exist anymore. It's a pure compiler feature. The compiler turns a text blocks into something in the bytecode that looks exactly like the translation of a string literal. You have no way to distinguish, once you have bytecode, whether the string literal that you're seeing was a text block or not. It's purely during compilation. And still, this information is put there, seemingly to annoy us. I'll explain later that that's not quite the case. So I have to again run with enable preview, and then I can run my text block example. The annoyance gets even bigger when I realize that if I launch it with 15, it still doesn't work. You would think, well, the feature doesn't change, and it's now final in 15. Can I just run this with 15? And the answer is no, you can't. It's even worse. You cannot run this with 15 at all, with or without preview flags. It just doesn't work. It just refuses and says, this was compiled for 58, which was Java 14, but this version of the runtime only recognizes preview feature for class file version 59. So that's version pinning. What that means is if you start writing preview features, you must compile it and run it on the exact same Java version with enable preview activated. And the reason for that is that OpenJDK wants to prevent accidental use in production. Preview features are production ready in the sense that they are safe and performant and thought out. That's all good. The only thing that they do not have, that Java features always have, is this implied stability, that you know this is a language feature now, I can use this till the heat death of the universe. This is not the case here, because this can change. It could technically be entirely pulled. And so you do not want to write a bunch of code, you don't want to get text blocks and then write 6 months worth of code with a team of 20 people on that, and then text blocks get changed or pulled, and then you go back and revisit all of that code. Clearly that's not a good idea. For text blocks, that would have not have been that bad, but imagine lambdas, right? Everybody uses lambdas once they come out, and then it's like, oh, no, we're going to change that. We're going to turn the arrow into the squiggly line arrow, and then you go back through, hundreds of thousands of lines of code. It's there so that IDEs can get up to speed earlier, that they have some releases time to experiment and support these new features, that we as users can experiment and give feedback. And if you write a small amount of code that you are willing to recompile, hobby projects or demo projects or just internal tools, right, that maybe your company uses internally, that's what this is there for. Use it there. And if you have feedback, take that to the mailing list. That's what this feature is there for. The question is this feature surfaced correctly, and are there any unforeseen edge cases? And if you find an edge case or think that, no, this is weird in this one case, it's weird in this one case, with an edge case, or generally a different way of approaching this would be better, this is the time to give that feedback. Ideally, not just as a keyboard warrior who sits at home and has like, oh, I just in the last 10 minutes thinking about this problem, I thought this would be a better syntax. What is really valuable is here is I tried to put this into my project. And this is where it failed or where it didn't work, or whatever. And give specific feedback driven by the projects that you use this in. That's by far the most actionable feedback. Okay, so once I have a preview feature, how much does it still change? So let's say on the surface, like on some syntax details, you could actually argue change quite a lot, specifically compared to Java, which is otherwise extremely stable. But they do usually finalize. And I'm going to ask for each of these steps, these 3 numbers. I'm going to guess, sorry, these 3 numbers. How long does it take for a feature in this stage to get to the next stage, so to finalize in this case? How much does it change during that time, and how many of them actually make the jump? And clearly, many of these numbers are just gut feelings and guesses, right? So some of them I can look up. Duration is usually 1 to 2 years. That's based on actual numbers that you can look up. The rate of change is guesswork. And the rate of progression, you can count that. At the moment, the rate of progression is actually 100%. Every preview feature eventually made it to be final without too many changes. But I don't want to overpromise. Let's say there was a fluke. So, things could theoretically change. And there we have it. That's a preview feature. It's there to solicit feedback whether the solution was surfaced correctly. And so we can experiment with it without accidentally putting something in production that then falls apart when the feature changes. Let's go to the phase before that. Let's talk about proposals. Proposals are defined as JDK enhancement proposals. Shortcut for them is JEPs. For the longest time, I thought JEP was a Java enhancement proposal. You can find like 5 years of me saying that and writing that everywhere. Well, you can't find me writing that anymore because I went back through time and fixed all my blog posts. But yeah, so that's wrong. It's a JDK enhancement proposal, which if you also then unroll JDK, it's a Java Development Kit enhancement proposal. That's why we say JEP for short. If you know architecture decision records, that's basically what this is. I have a few examples here that are currently being proposed to be included. Statements before super means that if you have a constructor and you call another constructor, be it the super constructor or this another constructor in the same class, you cannot have no statements before that. That's not really a technical limitation. You could put statements there, but then they have to fulfill certain properties. And so in the past, the decision was made, it's just easier if we don't allow this. This might become possible in the future, maybe in a limited sense. Read that JEP if you're interested in that. Compact object headers are just going to give you for free some of your memory back. You can expect 5 to 15 or 5 to 20%, if I remember correctly, of your heap just being free and being you can use that elsewhere, or just use the same heap and get more data in it. Multi-file source programs are also very interesting. At the moment, if you're in a recent Java version, you can type, as I did earlier, Java. Well, actually, I didn't do that earlier. You can type Java and then a source file, and we'll compile in memory and run it. At the moment, you can only do that with a single source file. In the future, you might be able to do this with multiple source files. If any of those features interest you, go look up the JEPs. Everything that's green here is a link. I will give you a permalink to the slides later. They're also already online, by the way. If you go to slides.nipafx.dev, I'll give you another link later. Point I'm making is, we're not going to go into these details here, into those features. If you're interested, go look them up. Okay, so every feature has two parts, right? It has a specification, and it has an implementation. So how do you specify what a JEP is? You write a JEP for it, which is slightly confusing, but it's true. JEP number 1, fittingly, introduced the concept of a JEP. That was done in 2011. In 2014, there was a JEP 2.0 draft. Again, there's a draft here. I don't know why, because this is now close to 10 years old. It's clearly in practice. No idea why it's a draft. And one thing that that draft contains, which is really funny, is this cool diagram, which is not going to be on the test, so don't worry, you have to learn it. You don't have to learn it by heart. I just want to go quickly through just the outlines. So these are the different states that a JEP can have, from it's in draft to all the way it's done. And then there's a bunch of arrows about who can do what, who can close it or propose it to the next level. That's all organizational stuff on the bottom left and top right. But this diagonal from draft to close delivered is what's interesting here. In the end, a JEP is just an entry in the Java bug system. So Java bug system, JBS, is essentially just a slow variant of Jira, which, yes, even slower, or Jira. And so there are filters here for that. So it's just an issue with a specific marker. And I filtered by these markers in different states. So if you're interested, you can click on targeted JEPs, and you will see which JEPs are currently being targeted. On June 13th, I went through all of those and counted those up, and just pulled out some numbers. We don't need to go into the numbers in detail. I'm going to use them later. I'm going to explain to you why. Let's put them on this diagram here. So 51 were back in June, right? 51 were in draft state. Then we had 33 in this phase that were somewhat active, and 13 that, if you mean, you could say they're dead. Let's just say they're dormant. They have not been changed in the last 3 years. So I'm not having high hopes that it was going to happen soon. A couple were withdrawn, a couple were rejected, and 291 were delivered. If you rewrite those numbers a little bit, we can see that of every feature that was ever closed, that was 340, all of them were drafted, a couple were withdrawn, rejected, and 229 were delivered. So of the ones, I mean, there's still current JEPs in flight, they would distort the statistics. So to compute how many do actually make it, I decided to only look at the ones that are closed. So at the moment, about 85% of the JEPs that are currently being closed were closed successfully by being delivered. Okay, so we just talked about how the proposals are defined in a JEP, and the JEP itself is also defined in a JEP, but they also often come with an implementation. Not every JEP has to have a public implementation. Sometimes it's only a prototype living on somebody's private fork, but usually they do. The big projects, like Valhalla, Amber, they all get their own fork of OpenJDK. And then if a feature is small enough, it might just get a branch. So in Amber, there's a branch called superinit that contains the code for the statements before super JEP. So if you're super interested, you can look into that branch, you can look into the diff versus the main branch, you can see what the difference, what this feature consists of. You can build that JDK if you want to, so even before this makes it as a preview feature into the JDK, you can build it and use it. And specifically on a Linux system, it's not that complicated to build a JDK. I was kind of surprised. I'm not a Linux hacker by any means. I'm not super comfortable with doing like close to the metal stuff. But my operating system also already had all the external libraries that I needed. And so mainly, I just cloned and ran make. mostly. So if you're interested in building the OpenJDK, specifically on Linux, I can only invite you to do that. It's not as terrible as you might think it could be. Okay, so what's the goal of a JEP? I told you about the goals of a preview feature, and it's more about, is this surfaced correctly? For a proposal, it's more, is this the right way to do it? So is this the good solution for the problem? The idea here is that that proposal now is in a phase where people thought about it long and hard, but now it's time to open up to a wider audience, so more people can think about it long and hard and give feedback. Yes, it seeks feedback as well, and it's also there to motivate, describe, and archive the proposal over time, right? So every JEP is still there, and it still defines why a feature that was introduced through a JEP in 2013 is the way it is. These proposals do change a lot, specifically while they're still in draft state. So draft state is the first state, and in draft state they can change a lot without any heads up. That has recently happened to the proposal for Markdown in Javadoc. Not sure whether you've heard of that. So Javadoc at the moment, right, has this HTML-like syntax, which is sometimes a little bit annoying, and there's a proposal to allow you to, or allow us to write what's essentially Markdown in Javadoc. There was a JEP draft for that, and that got some feedback, and then it was totally reworked. The new JEP draft is very, very different from the old one. So that can always happen. How long does all of this take? Again, I'm guessing sometimes it's really fast, and a few things take maybe 2-3 years, and there are outliers, right? There are JEPs, I told you earlier, there's JEPs that are dormant. By my definition, that means they have not been changed in 3 years. So clearly they are way older than this, right? So there's a long tail of longer projects there. How much do they change? I settled on less than half on average. Again, that's just a gut feeling, but the rate of progression we computed at 85% actually correct. And this mostly concludes the part that is, let's say, somewhat easy to observe. If you are on Twitter, on Reddit, or if you are looking at insight.java, which is the website that we run, I'm going to show you the link later again. All of that is mostly concerned with this phase, because this phase has a low volume of communication. Here's a JEP, and then you can read the JEP. Now let's go into the phase before that, the exploration phase and the idea phase. I have a few examples here. There's this idea of a wither on a record. I find that feature very cool, so let's talk about it for a second. Records are transparent carriers for immutable data. We've already seen that earlier today. So that means you cannot call set name on a record that has a string name field. There are no setters. The general, clearly, with immutable data structures, you don't have setters. But what you often want to do with immutable code, immutable data, is to take it and say, I want to have the same piece of data again with just this single change. Just this name field should be different. Everything else take the same, just change the name field, or rather, give me a copy with the changed name field. And the way to write that, if you write it as API code, you write usually with name, string name, and then the implementation is create a new record that looks as the old one, except with a different name. And writing that is even way worse than writing as a setter, because it's more lines of code, or a longer line of code, depending on how you write it. It's very terrible. Obviously, your IDE can generate that for you, which is also not great, because you still have a chunk of code that you need to check, like, is it really doing what I hope it's doing? And so there is a concept of a language feature for withers. So you don't need to write a with name method. You can just write old record with curly braces, name equals foo, and then a lot of cool things happen under the hood, and you get your copy back. Again, we're not going to get into that. You can read the design notes there. I'm expecting a JEP for that somewhat soon. So Brian Getz, who's the lead on some of these projects, who's working on all of this, whose ideas I just talk about here basically, not just his ideas, but he drives a lot of this forward. At DevOps Belgium, he gave a talk. He also presented withers there, and when he's ready to talk about this stuff publicly, usually that means it's not that far away anymore. There are a few more ideas here, and you can see white papers, email thread, design notes. All of those things are very unstructured. People just, doing this any way they want, and that's true. These are not specified. These can be mailing list and changes. People have meetings and design notes over them. Often prototypes are being developed. Often more than one, actually. Like Valhalla is notorious for this. I think Valhalla is like on its 5th stage of prototypes. Some things are just complex, and the first exploration doesn't get there where you want. Even worse, I think Valhalla started explorations in the knowledge that this is not going to be the solution, just to see where this takes us, or where it takes the OpenJDK community, and to see where things go. Conference talks, JBS issues, this can happen in whatever order really, but roughly it works like this, right? If you can hear about it in a conference talk, if you see an issue, it's already pretty far progressed. This is the first step that we've looked at that is entirely unspecified. It's also unstructured, and that means everybody can contribute to it. Right? I cannot open a JEP. I'm not a member of OpenJDK, but I can subscribe to the mailing list and annoy Brian with my emails. Did you ever think about this? So that's the kind of thing you can do there. Which means also that depending on the topic, there might be some bike shedding on the mailing lists. Some more complicated stuff often gets less feedback because more complicated stuff takes more than 10 minutes to think through. You have to sit down, you have to maybe build the version yourself, you have to experiment with it for a couple of days. Clearly that's not something that people can just do while they're having a regular job on the side easily. So there is no barrier for contribution in an organizational sense. But to give good feedback or to give good ideas, you often have to invest some time to experiment with it. The goal here is to assess feasibility. Is this even something that we can do? And to shape a general idea into a specific proposal. We have this idea, can it work? And if it can work, how specifically must it be designed to work? And also to estimate complexity and effort. It's not impossible that in this phase it turns out that yes, this is possible and it would be cool, but it takes so much time that other things are just more important right now. So let's bench it for later. So the considerations are, does this fit into the Java and the ecosystem? Can it be implemented? Can it be introduced? Is there a way from where we are to where we want to be? Generics are a great example in that. Generics clearly were designed in a way that allowed old code to still compile and the entire ecosystem to start using generics in a decentralized manner where everybody could start using generics without everybody else also have to do it. Lambdas were a similar example. Lambda were not just a new kind of type that was bolted on the side, but every functional interface, every interface that only has a single method, of which Java had a lot way before Lambdas, can now be used with a Lambda. And if there's an API that you want to use that has a functional interface, you don't have to write Lambdas to use it. You can just write an anonymous implementation of a class if you want to. So it's very important to figure out, can we get there? Not only is that a good place to be, but can we get there from here? And that's often a very big question with Java, right? With all of these features, it's always a consideration. A good example for this would be, where this doesn't work out, is something like nullable types. It would be really great to have a null-aware type system where a string is a string that is not also null. But there is no way, I'm not saying there cannot be a way, but there is no known way from the Java that we have to the Java that has a null-aware type system, and you can get there without having to rework the entire Java code base that exists, all the code bases that exist out there, often in a way that is backwards incompatible. So it cannot really be easily introduced, and so it's probably not going to happen. I have a whole talk on that in detail. If you want to know more about that, you can ask me. I can tell you probably about a bunch of the features that you have in mind, why we can't get them in Java. That's that's a dark part of my job. I also got that from Brian, going around telling people no, but with an explanation why. Because for most ideas that I have, at least, somebody smarter already had that idea and thought through the implications, and can, if you asked, especially if you ask nicely, you often get a good explanation of why that's the case. Okay, and as I already said earlier, what priority does it have? Is it possible? Yes, but is it worth the effort? And during these exploration phases, features evolve a lot, and fundamentally, and all these numbers are super hard to guess. Rate of change can be way above 100% if you rework ideas several times. I told you about Valhalla, which is on the fifth prototype or fifth implementation right now. So clearly, if you have a solution and then you throw it away and create a new solution, you already changed 100%. And you can do that several times. How long does it take? Some features happen really fast, like text blocks popped up and then were basically in the next Java release as a preview feature. That was pretty fast. Oh, sorry, not text blocks, string templates. Text blocks was a different route. Text blocks first was raw strings that were merged, and then last minute they were unmerged, and then a release later text blocks popped up, which implemented a part of that. The rate of progression, again, is hard to guess. One quarter to 3 quarters? I mean, that's a difference of, that's a factor of 3 between, right? So it's very rough. But I want to say, once somebody sits actually down and tries to figure this out, often we get something out of this. The phase before that, the idea phase, is way worse, right? Every time we have a problem and oh man, this one thing and now I would be done, but no, I have to write all this code. That's definitely not me, I would never do that. This is also something that is fun. Every Java programmer who knows this one other language says why don't we have this thing that the other language has? And even Brian Getz has so many ideas, he needs to keep track on a notebook. This is not just a stock footage image of notebooks. I actually asked Brian to take a photo of his notebooks. So he has like a bunch of them. And I recently, for the first time, had a meeting with him where, not me, but some other people talked about the features. And he just pulled out the notebook and starts writing. Incredible, people still do that. But yeah, so the ideas basically is what I'm saying. The ideas are cheap. Everybody can have ideas all day. I have ideas about how to change Java, but it doesn't matter. Like if you just have an idea and don't take it anywhere, that doesn't get you anywhere, right? Execution is the part that counts. That's the tough part, where you sit down, you try to think this through. That doesn't mean that ideas are worthless. I didn't say that, just that they are cheap. And specifically in context of other languages have this feature, why can't Java have this feature? That's a great example of, that's a good starting point, but that's only where the exploration starts. That's not where it ends. It's not like Scala has this, or Kotlin has that, or I don't know, C# has that. We need this, done. This is the exploration phase. No, that's not how it goes. It's a good starting point to figure out what would this feature look like in Java? Which other languages have that? Which mistakes did they make? What can we do better? Java occasionally talks about the last mover advantage, which is not having a cutting-edge solution while it is still cutting edge, and then cutting your users with that edge, but instead, once other languages have it, see how things work out there, and then try to find a solution that fits well into Java, so we can get back to that, why does this take so long? But that also tries to avoid some common pitfalls. A good example of this would be string templates. String templates force you to put this str, fmt, whatever processor at the beginning. And that means if you do something that uses, if you don't know about string templates, don't worry. But for those who do, if you write like SQL or XML or something, you don't want to put this together as a string. You want to have an XML parser put this together to a string, or maybe not even to a string, but to a rich object, and a thing that understands XML. And so instead of saying, well, first we interpret the string as you want, and then later maybe you think about having it checked. No, the language forces you to put some processor there, and since it does that anyway, hopefully we are in the situation to think it's XML, so maybe I'm going to look for an XML text processor and then use that here. What I'm meaning is other languages, some other languages, just give you a string interpolation, which makes it very easy for you to create all kinds of buggy XML or injection attack SQL without giving you a good mechanism to fight those problems. And Java learned from this, like, no, let's put the thing that can cause problems and the solution to that problem next to one another, so you are at least inclined to think about that. So actually, I think I went through a bunch already just now. So the consideration is this a good idea? Is this a good idea for Java specifically? And is it a good idea now? Or do we need some other features before that or in the future? And if you try to guess any of this, it's terrible. I didn't even try. This is just up there, right? As I said, like nobody can count how many ideas people had about Java. Okay, now we went from ideas through explorations, proposals, and previews to feature. But I smuggled a new item onto the table of contents that I didn't talk about earlier. And that's feature evolution. Even something, technically, that would be low at the very top, but you will see in a second why that would be very weird. So what this is about is, well, not everything in Java is really final, right? We've seen some deprecations, something got removed, so it's not like it literally everything stays until the heat death of the universe. So even Java features aren't quite that final. So let's talk about those. Let's have a look into this, and let's look at the considerations. If a feature starts to hurt either the users because it's, for example, cumbersome to use, or more often than not, it's not so much that it's cumbersome to use, but it's actually dangerous to use. It's hard to get right. It's easy to start using and hard to use correctly. That's, for example, one thing how it can hurt. Maybe it just hurts during the development. Maybe its feature is not very widely adopted, but it causes a lot of work within OpenJDK and needs to be constantly touched and retouched on every new feature. And that would be a reason to maybe remove it because it hurts not the user of the language, but the developers of the language, which means it binds resources that are not invested into improvements. If something hurts and is not used, clearly it's easier to change or fade out as opposed when it's used. Maybe there's a way to improve it, and if it's removed, how much would that hurt? I brought a few examples. For example, something I got removed is the single underscore as variable name. We briefly had this discussion earlier. So that's now the unnamed pattern or the unnamed variable. Up to Java 7, you could just use the single underscore as a variable name. By the way, you can still use the single underscore in variable names, just not the single underscore on its own as a variable name. That gave you a warning in 8 and was removed in 9 with the idea to reintroduce it later for what we get it now. So that was rarely used at all. It prevented a very useful language feature and was quite easy to fix. All you need to do to fix this is to basically do a search replace for this. I mean, probably there are easier, better ways to do this, but that essentially would have been enough. Although you would have to write a smart regex so you don't replace all the underscores in your code base. But I'm sure you, well, most of us got past 8, so most of us figured it out somehow. I think the rarely used part is very important here. Really, very few people use the single underscore as a variable name. Concurrent mark sweep, the garbage collector, got kicked out. Constant maintenance cost, there's a lot of alternative GCs that do this, most of them do the same job better, or do different jobs, also better. And it's also pretty easy to fix. You don't need to touch all of your code base, you need to touch a few launch scripts, right? So that's easier to ask to fix than something to the languages. RMI activation is obsolete and basically unused, also easy to phase out. Phase out? Phase out? Ah, well. And a few other things that are a little bit more interesting are current terminal deprecations. So these things are currently being in the process of being removed. If you use them, you will get warnings to different degrees. Primitive wrapper constructors, for example, you will in the future not be able to write new integer, whatever, 42. And the reason for that is that if we get value types or primitive types, depending on, I think primitive types is the current vernacular, so I should change this. Value types is the current vernacular, so it's not primitive types. You have to use integer.valueOf. This is now a warning, and these methods will, these constructors will disappear. And that's already like a kind of a deeper change, right? That means that your dependencies and your code actually do need to do quite a lot of work to change that. But if we don't do that, there's a bunch of improvements in the Java language that we don't get. So this is a little bit of a more intense exchange where we have to do more work, but we also get a lot back. Whereas something like Applet API is a much more shallow change. Nobody uses it, so let's just remove it. Or basically nobody uses it. Finalization is a good example for something that exists and that's easy to use and hard to get right. Also has a consistent maintenance cost. The garbage collection team, oh, there's a typo there. It's called performance, not performance. If the ZGC garbage collection team, they estimated that without finalization, you get about 1.5% more of your heap to use for yourself, because that's the amount of heap that they need to track this feature. And there are better mechanisms. So you can see that there's this is a good example of something that would really, it's not necessary to remove it, but it's really helpful because we lose some footguns, we use better mechanisms, and we get some performance on top, and then the maintenance of the JDK also gets easier, which is always good. If you're interested in more of this, I made this video on the Java YouTube channel, Prepare Your Code Bases for Future Java. That looks like my dad, but that's what my manager, who's also doing my thumbnails. I don't know, I hope he didn't give my image to some AI, but that's how he made me look, which is, I'm supposed to be a security manager in that photo. Doesn't matter. Have a look at that newscast if you're interested. It goes through all the current deprecations, tells you how to find them and what to do about them, and it gives a little bit of background why they are being removed. Okay, so how often does this happen? I don't know. How do you guess? You could maybe diff the JLS, but I'll just guess way less than 1 in 100, right? Maybe even just 1 in 1,000. Who knows? Most features survive and live a long time. So you got all that? Or should we go over it in correct order one more time? Okay, so first somebody has an idea, can this be good for Java? And that's easy to have, and then starts the interesting part, and the part where the hard work comes in. You need to explore. How can this be implemented, and how can this be introduced to Java? And these phases are not exactly hidden, specifically exploration. If you follow all the mailing lists, then you can observe this. But it gets much easier once we get to proposal phase. Then the question is this the best way to implement it? And you can also see that quite a few thoughts or quite a few avenues are already closed off, right? The question, is this even worth solving? Is already mostly answered. Is this worth the time to work on it? Is also already mostly answered. So a bunch of questions that you would ask in the development phase of a feature are already done here. So once we observe a proposal, a big chunk of the work, I would guess often more than half of the work, is already done in the past. So we see it somewhat late in the phase, is what I'm saying. Once we see it as a preview feature, it's even later. Now the question is no longer, is this a good solution? It probably is. The question is this the best way to shape the solution? And since we work mostly with the surface level, that might seem like deep changes to us, but going back to Project Valhalla, once the JVM understands how value types work and the just-in-time compiler can optimize all of that, and once all of that is settled, how exactly we have to type out what a value type is important to us, surely, and it's important for how the language works, but most of this important hard work is already done under the surface. Now the question is only, is this the best way for us to use it? And once a feature is done, there's always this like question in the back of somebody's head, does this feature hurt? Do we have to remove it? We also, personally as Java users, probably have the one or the other feature where we wish we could just, take it behind the barn so that our colleagues stop using it. And here I try to force everything else that I talked to you so far into this table. First column is specification. Proposals are specified in JEP1, and previews and features are specified in JLS. Artifacts are conversations and just notes for ideas. And then we often start getting issues in the exploration phase, but really important, really interesting does become in the proposal and preview phase, where we start seeing code, usually publicly available code. And in the end, the feature, of course, is also in the JDK code base. How long does this take? This is all the estimates that I put down here. What's the rate of change? Again, all the estimates. And you can see almost as if I picked the number because of that, but I honestly picked the number because I thought they were that, but they pan out pretty well. You can see how the rate of change goes down. You can see how the survivability goes up, which is what you would expect, right? The more work goes into an idea, and the further it gets without dying, the more likely it is to actually become a feature. Until in the end, it is a feature, and it would, live forever, except of the very, very few things that get phased out. Two technical comments. First of all, there is a concept of incubating APIs. That's a phase before an API becomes preview. So at the moment, the structure concurrency API, for example, is in preview. Before that, it used to be an incubating API. And personally, I would put incubating APIs not in the preview phase, but into the proposal phase. Yes, we can already experiment with it, but it's guaranteed that this feature is going to change. If for no other reason than incubating features, you need other command line flags, it's a different module and a different package, and all of those change. So a lot of stuff still changes there. So that's why I would put into proposal phase. And while a preview feature is basically is done on the implementation side, it's rock solid as every other Java feature. That's not the case for incubating APIs. Incubating APIs can have sharp edges. They can have an implementation that just maybe does the wrong thing in one of those cases. It's intentionally in a very early phase still. And not all APIs get exposed like that. And then on the topic of JEPs, we talked about those a lot, but it's not like all proposals need one. The bigger proposals need need a JEP. And if you have a big bunch of JEPs, you often do this under the roof of a project, like Valhalla, like Amber. But there's a ton of changes that goes into every JDK that does not fall into this category. Bug fixes, performance improvements, just like let's add a smaller method here or something like that. A lot of that happens that only exists in JBS issues. JEPs are really just like the big things that are more noteworthy, that we want to look at for a longer time before finalizing them. And at the end, I want to touch on why we have this complicated process. Or not complicated, but this lengthy process. And a big reason for that is that whatever changes for Java changes the work of millions of developers. I don't know how many there are. Every time you ask Oracle, you get 1 million more, I guess. So it's like 9 to maybe 15 is the number I recently heard. It's a lot, right? It's like in the 2 digits, millions of Java developers. Clearly, surely there are billions, maybe even trillions lines of code out there. It's hard to guess for me. A lot. And a very important part is that we live in very, very different areas, right? Many of us live in the industry part, where we code for customers. That's a big chunk of Java, clearly, but it's not all the only chunk. A lot of research teams work with Java. They're developing stuff. I worked for a research institute once. Those people wrote more code for more times during the week than most than most professional software developers, because they didn't know about stand-ups, they didn't know what tests were. They just sat down Monday morning and wrote code for 8 hours and then went home, because they were working on like some kind of model for the markets or energy markets or DNA or whatever, right? So they're modeling stuff a lot. Games are written in Java. Minecraft is the best, most commonly known example, but there are other good games written in that as well. I can recommend Slay the Spire. It's a cool roguelike deck builder, available on Steam, really professional game. You wouldn't think it was in Java, but it is. A lot of people, do their hobbies with that. People learn on that. And so that's a big number of very different use cases for the same language. And we always only see like our angle on that. Like most of us fit in probably at most 2 of those categories. And so a change in Java impacts way more than each individual member of us can see, which is why it's helpful if these features get surfaced slowly so that the whole Java community from all of these angles can give feedback on that through the mailing list, for example. And in the end, also, probably important to my employer and others, billions of euros of annual revenue flow through Java. Not companies earning money with Java, I'm just saying, banking that works, that works money on top of Java, that Java is routing that lots of services are being offered through Java, and that's a lot of money, and it's better to be safe than sorry. Brian Getz often says this promise that Java is backwards compatible, even though we do make some minor tweaks here and there, but we don't make like new feature X is going to break the language. You can only break that promise once, because then nobody's going to believe you anymore. And I think that's a good take on this. And so yeah, I want to close with that better safe than sorry. Thank you very much for your attention. I'm going to leave this slide up for a moment. As I said earlier, insight.java is the website for you if you want to observe this process for different kinds of features. It's a link aggregator, essentially, which links to new jobs, interesting mails on the mailing lists, other things that we produce, like videos. If you're more interested in just what the feature looks like in the end, go to dev.java. And yes, .java is a top-level domain, and no, we cannot get our websites there. Oracle is not handing them out, unfortunately. You can go to the YouTube channel from Java, youtube.com/Java, where you can see videos from myself and all my colleagues on topics like this. And yeah, do you have any questions?
Thank you for the presentation. Amazing. What would you say is the big stopper when you try to deprecate and remove features? Because Java is 25 years old and a lot of things piling up.
Yeah. So first of all, the idea is that if a feature is widely used, like throughout the entire ecosystem, and would require a lot of change and a lot of different projects, then that puts the bar very high for what do we get out of it. What's the feature that we're enabling with that? Right? Some features are unused and they're just a hazard, so it's easy to remove them. But something like new integer is used a lot, and removing that requires quite a lot of work throughout the ecosystem, and then the bar needs to be higher for the value we get in exchange for that. But the more important consideration is whether there's any kind of chaining. So let's talk about the removal of the integer constructor. Everybody can do that on their own in their own code base, and it just works. But there are other features that if you would remove them, or if you would introduce them, you would have like a chain dependency where I cannot do this until my dependencies do it. I need to update my dependencies first, and only then can I do it. And that's even worse, right? So now not only everybody has to make a change, now somehow everybody has to coordinate throughout our dependency chains. And if you're using Spring and the like, you know that those can be pretty deep. To coordinate on that, on making this change. And those are big hurdles that you would have to give an awful lot of extra benefit to make it worth it. So let's say we'd all agree that stream pipelines are the way to go and for loops are stupid and should leave. That's not my actual opinion, but let's just make it a straw man. That's not going to happen. Because clearly for loops do not hurt anybody, and you have to change every Java code that's out there. So that's maybe that answers your question.
Okay. Yes, it does. Interesting that you mentioned the integer, because I thought it's a search and replace, so it should be easy to remove, but...
yeah, it is, that is the case, but still everybody has to do it, right? Yeah. And by the way, for changes like this, there's Open Rewrite, I think is the project that has this kind of recipes that you can apply. And new integer is basically just a regex, right? Also, I'm very curious, and I just thought about that while I gave that presentation. I'm not sure how much longer it's going to work on the bytecode level. So surely the language will soon tell you it's already deprecated. It will soon just not allow you to call that constructor anymore because it's going to be private. I wonder how long the bytecode will keep working, because because I can change my code easily, but if I still use code that was compiled for Java 4, what then? So I'm not sure whether they get special treatment, whether old code can still call the constructor. I don't know. Although that would have changed semantics, so I guess not. Interesting. I don't know.
Well, great talk. As always, thanks for that. And my question is, I think, quite similar to the question earlier asked. So this is about backwards compatibility. So you don't want to break it well, you get to break it only once, right? That's what Brian said. So what is the criteria, or what is the, let's say, thing that you base that decision on, where you have, for example, you discussed about the unnamed variable names, the single underscore. What criteria you go through to decide that, okay, let's use this so that, well, you will break the backward compatibility, but then it is okay to make that decision.
Yeah, so let me talk a little bit about backwards compatibility in general. There are like tons of ways to be backwards compatible, right? You can be source compatible, you can be bytecode compatible, behavior compatible. Technically, every bug fix is a behavior change. So if you could really insist on it, you could say like a bug fix that we recently had was if you create the double 1e23 and you tell it to turn itself into a string, you get got very many 9s.e22, which is broken. It should be 1e23 as a string. We now get that behavior. Technically, that's backwards incompatible change, right? Now we update Unicode to the recent Unicode release, and now you get, when you have a time which says like it's 3 p.m., you don't get 3:00 space p.m., you get a narrow non-breaking space, which broke a bunch of tests which would parse and format strings. So those kind of changes always happen, right? So minor changes, they don't even really count, so to speak, specifically not bug fixes. For the bigger ones, yeah, I can just repeat what I had. I don't think there are strict criteria that somebody has like a table with a checklist, but the question is how big is the impact and what do we get out of it? And as for impact, not only are these things made public and there's like phases to get there, but also OpenJDK, or specifically Oracle, has access to a lot of code bases, not only open source code bases, but also just company internal code bases. So Oracle itself develops a lot of stuff on Java, right? It's not part of the group that develops Java itself. It's just web logic written in Java. So, and those code bases, clearly, even if they're not open source, the people who work at Oracle have access to. And so what usually happens is a corpus analysis where people working in OpenJDK, and I'm sure similar things are true for other people in other companies, look at open source, but also at internal code bases and see how widely is this really used, like the underscore. Does anybody really do this? And how many and how easy it is to fix? So I think, how widely used is it? How easy would it be to change that? Is there like some kind of chain dependency? And then, but very importantly, what do we get out of it? Like, do we get something? And the unnamed patterns are very, very cool and very useful to avoid default branches. They're an essential feature of using this kind of pattern matching. And to give all of that up just because a few people like me used the underscore once is not worth it, I think. Any more questions? Other than that, I'll be here the rest of the day, including the what is it called, the meetup, the hangout later.
Yes, meet and greet at 5:30.
Exactly, that thing. But I will not be here starting tomorrow, so if any more questions, do find me, and I'll answer anything today.
Thank you a lot again, Nicolai.